So one of the things I would like to do in this video is at least spend a little bit, maybe spend a little bit of time understanding really again what the idea behind a value constructor, something that happens to be a type constructor, okay, and somehow how does meta a how does kind fit into all of this. Okay, so let's start with something really simple, something that we're already familiar with. So if I ask you, give me the signature to what the type for this method plus happens to be. So I have a method plus, okay, and if I need a type for the plus method, it's basically going to look something of the kind. Again, from a very high level, I'm just saying it takes in something that's a number. It takes in something that's a number as a first parameter, and it takes in a number as a second parameter, and out comes back a third number, okay, which is the addition of the first two numbers. So the values that I'm going so if I'm going to create a value, if I make a transition from, so this is everything in blue over here is my type world, okay, this is basically my type world. And if I make a transition to my value world, and if I say, okay, let's use this, let's actually use and create some values out of this function. So one way I could do that is if I were to use the prefix notation, I could say that's my function plus, and I'm going to pass in the value 5, pass in the value 6, and this 5 is my first number, 6 is my second number, and the addition of 5 and 6 in this case is going to give you back the resultant, which is 11. Okay, now in some sense, what prompted me to come up with these values 5 and 6 in the first place was that this type was actually guiding me. It was telling me what can be provided as parameters to the plus method and what are the parameters that you cannot provide. I cannot pass in a string. I cannot pass in a list. I cannot pass in something that is not a number and expect to get back a resultant of that parameter with some other parameter. That's simply not going to work. As long as I provide numbers, that I'm going to get back the correct, at least the resultant of those two parameters. So in some sense, the type is guiding what are the things I can do in the value world. Now, okay, so this is all fine. This is all good. Can I just give you one more example? So let's see if I created my own type. If I created my own type now, let's say data. This is actually already in Haskell, but let's say data a maybe of a equals to equals to just a or 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 nothing. Okay, so what's happening here? Now, what's happening here is the two key, at least two critical pieces of information as part of this type declaration. First thing that I see over here is something called a value constructor. Now, what is a value constructor? A value constructor is something. Think of it as a function. It has a type, just as this function plus has a type there. The value constructor has a type too. So what's the type here? So just to be consistent, I'm going to use again blues for my type word, and this tells me that in order to use the value constructor or the method adjust, is basically it basically takes in as a parameter some type A. Okay, so this is a type variable which has some type in it. It takes in a parameter, takes in the first parameter, and out comes back another value that has a type. It has a type of maybe 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 A. Okay, so this is the type. This is a type for the value constructor just here. And if I would like to create some values out of this, I can make a transition to my type to my value world, and I can say something of the kind where I can say, okay, let's use a method just now let's use a method or the value constructor just. It needs in something a, but is there a constraint on a? Where a could be anything, doesn't matter. It's just a type variable. So if I say just of 6, okay, if I call this right there and I pass in 6, what should I get back as an output? The output of this is basically another value. It's another value that has a type of maybe of a. So the type for this is going to be in this case maybe, okay. And instead of saying a, which is my type variable, I can now say this is 6, which happens to be an integer, so it's maybe an integer. Okay, that's the type over here. All right. So what do value constructors do from a very high level? It takes in some value and out comes back another value. There you go. It takes in some value and out comes back another value. Okay. So what is a type constructor then? A type constructor, on the other hand, is something that in some ways works very, very similar to what a value constructor does. But instead of just taking in a value and giving it back out as another value, it actually takes in as an input a type. Okay, so just to be a little bit clear here, what I have is this piece over here maybe is basically what happens to be a type constructor. And a type constructor, all it does, it says, look, I'll take in as an input a type, and out will come a brand new another type that just got created. Maybe it's not a type. It is a it is a mechanism, it's an approach, it's a constructor that will allow you to create a type out of it. Okay, so what can I pass in there as an what can I pass in as an input, or what kind of type can I pass in into maybe? Now, in some sense, the type for this value constructor guided me, or at least gave me some direction as to what I can pass in for an A and what kind of values I can get back. Likewise, what I really need is a type for a type. What I really need is a type of a type that would guide me or give me some idea as to what are the parameters that can be fed into this type constructor. Right? I just cannot pass in any arbitrary parameters here. Right? I need some kind of a high level kind of a signature that just tells me, okay, look, these are the types that you can pass in, and out comes back something else um, as as another type there. Okay, first thing, now this at least allows us in some sense to understand what a concrete type is and what a type constructor is. So this piece over here, maybe if maybe is a type constructor, then maybe of A, this entire thing in yellow, which is maybe of A, is actually the entire type. Okay, that's the entire type, meaning in this case maybe of A is the entire type, which actually got translated to maybe of an integer when you passed in an int as a value to the value constructor just there. Okay, so if that's the entire type maybe of A, then what this means is that every type which happens to be concrete like this, right, have a signature, or the type of a concrete type is basically a star. Okay, again, what does star mean here? Star just means that I have, it's basically the kind. Okay, so again, this could be also be translated into a kind. So if I ask what is the kind of an integer? Okay, so I've got a type. Let's do this. Let's just be consistent with my colors here. So I've got a value 6. What's the type for 6? The type for 6 is basically an integer. What is the kind, or what is the type of integer? Okay, so the kind for integer is basically going to be a star because it's a concrete type. Okay, likewise, if I do the same thing on let's take one more example. Let's just take in uh, let's take a value which is just let's do this. Let's just begin. I need to be consistent with my colors here. So this is the value world in green. The blue world is basically my type world, and in yellow over here, I'm looking at my type of my type. Okay, so if my value now happens to be just of 6, right? What's the type associated with just of 6? Okay, so if the value is just of 6, the actual type associated with that value of just of 6 is actually maybe an integer. So this is going to be maybe and integer. And what is the kind? What is the kind of maybe of integer? Because it's a concrete type, it's still going to be a star. It's still going to be a star there. Okay, now what I'm going to look at is something called, I'm going to look at something which is basically just maybe. Okay, now remember, maybe is not a type. It is not a type. And I know I'm being a little bit inconsistent with my colors here because I'm putting this in blue there. So let's do this. Let's not put it really in blue still. Let's just maybe put it in a slightly different color of blue. So maybe let's just put this in this, I don't know what color this is, but let's put it in this color here. Now, because maybe is not really a type, I don't have any value. I don't have any value yet that I can associate it with this type maybe. But the type of maybe or the kind of maybe is basically something that happens to take in a concrete type. It takes in a concrete type and will give you back as an output another concrete type. How do I know that? How do I even know? How did I even get this kind there? Okay, so remember, all of this in yellow is basically my kind. Okay, so how did I get a kind for this maybe? Okay, how did I do that? Well, I did that by just looking at this definition of my of my of my type maybe. Now, if you look at the value, over here, okay, if I look at just, let's say for example the value constructor just here. This is a type world. Because it's a type world, every single type in the type world must be a concrete type, meaning the kind of this A, the kind for this A over here must be a star because it must be a concrete type, and the kind for this entire maybe of A must also be a star. So what is maybe doing in this case here? Maybe, think of maybe as some kind of a function that takes in as an input this type A and out comes back this actual concrete type star there. Okay, so maybe takes in as an input a star, which is right there, some concrete type star. It could be anything as long as it's a concrete type there, and out comes back another concrete type, which is this entire thing. Okay, and that's how I figured out what the kind for maybe is. Now that I know what the kind of maybe is, right? I can I can I can do a lot of things. I can create a lot of types with that. Remember, I eventually would like to use this as my guiding. In some sense, it should help me. It should guide me into create various types that can live in this space there. Okay, in this type world in blue. Okay, so one of the things I can do over here is if I if I if I play with maybe. So what does maybe do? Okay, maybe should take in as an input some concrete type. So I don't know. Let's pass in a concrete type in, for example, and out comes back another concrete type, which is this entire thing. Maybe int is a concrete type, is an actual type. Likewise, I can do maybe char. This is a concrete type. Char is a concrete type, which has a kind of star, and maybe is a type constructor that takes in this concrete type, and out comes back this entire thing, which is a concrete type as well. Likewise, I can do maybe, I can do it on maybe on a list of integers. What does this mean? All it means is it takes this maybe a type constructor takes in something that is a concrete type. and out comes back something that is another another concrete type there. Okay. So this is basically the idea in some sense that should hopefully help you when you look at our next video, and we try to use some of this material in this video with some of the material at least start to learn about functors in the next video.